Silicon has become the primary driver of global economic and military strength, forming the invisible architecture of every critical digital system on the planet. In the Dalera Special Investment Region in Gujarat, that ambition is taking physical form as a 91,000 crore rupee investment, roughly $11 billion. The massive scale of this project raises a central question. Will this expanse of concrete anchor a global technology hub, or will it result in a subsidized industrial miscalculation? This construction represents India's high-stakes bid to join the world's most exclusive and fiercely guarded industrial club. This push is driven by the sharpening technology fracture between the United States and China. Washington is increasingly using export controls to weaponize the global supply of chips. At the same time, the world's reliance on Taiwan has created a vulnerability. A single company, TSMC, manufactures nearly all of the world's most advanced chips, acting as a global single point of failure. Under a strategy known as China Plus One, Western technology giants are now searching for neutral, reliable manufacturing locations to diversify their supply chains. India is using its unique leverage to capture this capital, offering massive state subsidies, political alignment with the West, and an immense English-speaking engineering workforce. New Delhi is utilizing this period of global supply chain anxiety to fund its own domestic chip-making capabilities. This map shows the current scale of the India Semiconductor mission. 10 major projects have been approved across 6 states, totaling 1.6 trillion rupees. In Dalera, the Tata PSMC plant targets 50,000 wafer starts per month by late 2026. To meet that timeline, Tata partnered with Dutch firm ASML in May 2026 for the specialized lithography tools required to print circuits onto silicon. Immediate proof of progress is already visible in Sonand, where Micron's assembly and packaging facility has reached commercial production. Through rapid construction and heavy state funding, the program moved from policy documents into physical infrastructure. Crucially, these new plants are not manufacturing the bleeding-edge 2-nanometer chips found in flagship smartphones. Instead, India is targeting nodes between 28 and 110 nanometers. While older, these are the essential technologies powering automotive electronics and industrial systems. This focus highlights the difference between fabrication, the complex process of creating chips from raw silicon, and packaging, where those chips are tested and assembled into finished components. By focusing on these high-volume legacy nodes, India is establishing a position within the essential hardware foundation of the global economy. Operating a fabrication plant requires immense resources, millions of gallons of ultra-pure water every day, and a constant, uninterrupted supply of power. Sustaining these water-intensive operations is a significant challenge in Gujarat, a state that has historically faced severe water stress. There is also a labor challenge. While India has a deep pool of software designers, it lacks workforce experience on the semiconductor manufacturing floor. Profitable yields depend on a highly regimented 24/7 environment, where a single microscopic error can ruin an entire week of production. While state subsidies can buy the necessary machinery, they cannot instantly create the institutional discipline and specialized infrastructure required to run them. This chart shows the government's goals, achieving 75% domestic supply by 2029 and 2-nanometer capabilities by 2035. Comparing this to industry leaders reveals the challenge. TSMC spent 30 years accumulating the knowledge India aims to master in 1 decade. India is currently leveraging favorable geopolitics and massive capital, but it is still working against the compounding nature of decades of research. The question remains, is India building the foundation for a sovereign technology sector, or is it funding an exceptionally expensive assembly line?